Hi Year 12 Maths students. We're just continuing with part 2 of our recurrence relations and applying it to simple and compound interest scenarios. So when we left off, we looked at the application of arithmetic sequences to a financial situation. And instead of using T, we use A to represent the balance amount. So if we look at the simple interest recurrence relation, you can see it's a very similar format to the arithmetic sequence. The only thing that you'll notice it's a little bit different is instead of having the common difference, we specifically say the common difference is the interest. And because we know that's the same amount applied over the course of the loan, to work it out, we simply use the principal and multiply it by the decimal interest rate. Okay, so we're going to try and apply this to an example just to see it working. So we've got our friend Cheryl, good old Sheza. She's depositing $5,000 into a bank account that pays a simple interest at a rate of 4.8% per annum. We have to construct a reoccurrence relation to model it, then use the model to find the value of her investment after 3 years. And lastly, using recursion, we'll have to find how many years her investment will exceed $6,000, and we'll get the calculator to help us do that. Okay, so the first step is always to go through and process your information and look at the useful information they're giving you. So because she's depositing the $5,000, we know that that's going to be our initial amount, or A0. And then we'll have to work out the decimal interest rate in order to work out the amount of interest she's paying every time. So we know that we've got to use the 4.8% per annum. Okay, so remember it's important to write down those bits of information before you proceed. Just if you make a mistake in that translation of information, at least we can see your methodology is right and we can see the values that you used. Okay, so we need to recall the recurrence formula. To put it together though, we need to find out the I value, or the amount of interest that's being added on every time. So using the I equals I over 100 times A0, we can work that out. So if we just pop that in our calculator, we can see that she's accruing $240 interest after every year. Alright, so now we can put together the recurrence relation. So using the format a to the n plus 1, whatever her balance is previously or currently, we'll add on $240 to get to the next balance at the end of each year. Alright, so that was part A. Part B, we need to use that model to find out her value after 3 years. So if we just start off with our initial balance, after the first year, after the second year, and after the third year is what we're after, because we need to use that recursion. Okay, so after the first year, 5,240, and after the third year, she will have $5,720 in her account. Okay, so part C, we need to figure out how many years old Shezza's investment will first exceed $6,000. Okay, so really easy to do on your calculator. Chuck in your initial amount and the interest that's being added. Then you can just use your answer button and repetitively add on that interest. So there's your 2 years, 3 years, 4 years. Looks like in the 5th year after she invests, it goes over the $6,000 mark. Okay, so very important just to document your answer and give a nice little concluding statement. So after the 5th year, Cheryl's investment will exceed $6,000. Alright, so let's move on to a compound interest recurrence relation. So remembering that we're just applying your geometric sequence, and they're essentially the same thing. So you'll notice to get our next balance, we simply apply our current or previous balance by this common ratio, and that's going to be the rate of interest that gets applied to your loan and investment. So the given formula for that is 1 plus your normal interest rate divided by 100 by K. And you remember that from Unit 1 and 2 where we had to apply the number of compounding periods per year. Now remember that your compound interest recurrence relation is also found on your formula sheet. So if you get stuck remembering that in your exam, you can just flick over to your formula sheet and see it there. I imagine why the simple interest one isn't on there is because it's probably not used very much in real life, so that's understandable. Okay, the last thing that you're commonly asked to do as well is to find the amount of interest that you've earned over the period of the compound loan or investment. And there's probably 2 common ones that you'll be asked. What was the interest over the full term of the loan or investment? And that's just simply the difference between your final balance and your initial balance. Or you might be asked the amount of interest earned between consecutive periods. So again, you're just finding the difference in their balances. Okay, so we're going to start off by looking at a simple familiar type question where we're only dealing with the loan or investment compounding once a year. So let's look at it. We've got our friend Darren, good old Dazza, loaning $4,000 from a bank. He's being charged a rate of 9.8% per annum, and we have to construct a recursion model for the value of his loan after n years' time. Then after that, considering he takes the loan after 5 years, let's work out how much he'd owe the bank using our recursion model. So firstly, I hope everyone would always annotate important information. So he's loaning $4,000, that's our principal amount. The rate of 9.8% per annum, that's the normal rate. We don't have to convert anything using K. We just simply work out our rate using the 1 plus I over 100 by 1. Right, and like every good math student, you would write down your facts. And we need to work out our R, so we'll add 1 to the 9.8 over 100 by the fact that it will compound once. We'll go whack that in our calculator. That gives us an R value of 1.098. So that'll help us develop our recursion relation. Okay, and then we can go ahead and okay, so that's A. We can go ahead and start on B now. So we have our recurrence model that we can use. So knowing that our initial amount was the $4,000, we can use our recurrence on our calculators. So remember, we can get the calculator to do the recursions for us. So if we times that by our 1.098, so that's after 1 year. Apply our recursion of 1.98 with our common ratio, 2 years, 3 years, 4 years, after 5 years, that's the balance. And like a good student, we'll document our working. Okay, so after you've written down all your working, we figured out that after 5 years, good old Dazza would have to pay back the bank $6,383.69. And even though the question doesn't ask us, we can see that he's the bank's going to charge him $2,383.69 in interest. Okay, I'd like you to have a go at question 5 example yourselves. And so press pause, have a go at it, and I'll check in with the work solution. Okay, how'd you go? So hopefully when you read the first part, you've got an investment of $2,000, interest rate of 7.5% per annum. Again, it's just compounding once a year, so you don't need to worry about applying your K value, and you're given the recurrence relation anyway. So part A, you're using the recurrence relation, so you're just finding A1, A2, A3. For B, it wants to know the interest accrued after the 3 years. So essentially, hopefully you interpreted that as the balance after the 3rd year minus the principal. And then part C is a little bit tricky. You just got to be careful of the wording. And it's between the 3rd and the 2nd year, how much interest was accrued during that time. So hopefully you got the same answers as me. Okay, the last thing we're going to look at this lesson is what happens if our compounding periods are more than just once a year. So usually a bank or an investment will give you a nominal interest rate, and that's not usually the whole picture. So you need to take into account how many times the loan or investment gets hit with interest, or the interest is applied over the year. So you have to consider what we call the K value, or compounding period. So just again from unit 1 and 2, hopefully you remember that your time conversions, so there's 4 quarters in a year, 12 months, 26 fortnights, 52 weeks, and 365 days. So your K values are those values. Okay, so we're going to have a go at just converting these stated or nominal interest rates into the interest rates that will be applied at each compounding period. Alright, so I'm going to have a go at doing a monthly conversion, and then I want you guys to go ahead and convert the others. Okay, so to do this, we just need to recall that to get our R value, we take the normal interest rate, divide it by 100 by the compounding period, and add 1. Okay, so let's do it for question 6 part 1. So So the R value is going to be 1 plus our 5.5 over 100 by 12 months in a year. So 12 compounding periods in that year. Chuck it in the calculator. Be careful to use brackets when you're including that compounding period. Okay, otherwise you'll get the wrong answer. So that gives us an R value of 1.0046. I'm going to round it up to. Okay, press pause, have a go at converting the fortnightly, quarterly, weekly, and biannually R values. Okay, so that's what I got for my R values. Hopefully you went okay. And what we're going to move on to next is some more examples that are inclusive of different compounding periods. Okay, the last two examples. So the first one's another simple familiar scenario where it's kind of stepping you through what to do. So we've got Diego wanting to invest $7,500 at a nominal rate of 9.6 per annum. You've got to construct a recursion model compounded quarterly and another one if it's compounded monthly. And then figure out the difference in interest between the two investments over a period of 6 months. Because you've got to use a recursion, you're just going to use your calculator again to help you do that. And the last question, we've got good old Courtney Courts. She's investing $50,000 that compounds monthly, and you've got to develop a recursion model to figure out how much is in her account after 2 years. Okay, so I'll work through the answers. If you just want to try it yourself, press pause, and then you can check in. Alright, for those working with me, I would always be in the habit of identifying key pieces of information. So our $7,500 is our initial amount, our 9.6 is our I, quarterly means K is 4, monthly means K is 12. And because we want the difference in interest between the investments over 6 months, when we come to doing that, for the quarterly one, we know that there's 3 months in a quarter, so essentially we want to compound it over 2 lots of quarters to get to the 6 months, whereas for working out that for the monthly one, there's 6 months, so we're after 6 compounds to get our balance. Okay, so for part A, if we're compounding it quarterly, we use a K value of 4. So calculating the required R value we need to use in our recursion model, we'll just chuck in the 9.6 divided by 100 by 4, adding 1, and that gives us an R value of 1.024. So our recursion model for our compounding quarterly is a to the n plus 1 is 1.024 by a to the n. If we change the consideration to be monthly, K is 12. So we do similar thing and we get a different R value of 1.008. So our recursion model for monthly is a to the n plus 1 equals 1.08 by a to the n. And to start C off, like I said, you need to figure out how many recursions you need to get to the 6 months. So for the compounding quarterly, there's 2 quarters in 6 months, so we need 2 recursions. So we're after the A2 term of the balance. If it's compounding monthly, for 6 months we need 6 recursions to get to 6 months, so we're after the A6 balance. Alright, let's just check the recursion models. So using the quarterly one, we know that we have to do only 2 recursions to get to the 6 months. So after 3 months and then after 6 months, we have our balance of $7,864.32. If we're doing the monthly recursions, we have to do 6 of them to get to the same 6-month period. And then after the 6 months, we can see the balance got to $7,867.28. So if I take those two values, I can find the difference between the two investment offers that it looks like Old Diego is considering. And even though the monthly one does work out to be more interest, you can see that it's not much more interest. Okay, so finally working through Courtney's problem. She is investing $50,000, so that's my principal amount, my A0, compounding monthly at a rate of 4.5%, and also considering our K value of 12. So we want to find how much is in our account after 2 years. So considering that it compounds monthly, we're after the A24, the 24th term. Okay, so after figuring out the R value and our recursion model, it's going to take a bit to get to our 24th recursion. So I'd kind of expect you to show this sort of working out where you're demonstrating that you know how to apply your recursion, and then like it's just simply a matter of putting it into your calculator, and after the first recursion, we're on $50,187.50, and then remember you can just use your calculator to come up with the other 24. To get to the 24th recursion. So second recursion, third, fourth, fifth, sixth, seventh, eighth, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th, 21st, 22nd, 23rd, 24th. We got there. Okay. And this also demonstrates when it comes to longer compounding periods, our compound interest formula comes into play, which we look at in another lesson down the track. Okay, so after that 2 years, good old Court should have $54,699.51 in her account.